rotation. So when you rotate, a rotation is a transformation where a point moves based on an angle around a center of rotation. And there are multiple angles that we can talk about, but we're going to really focus on three different angles, which are 90 degrees either counterclockwise or clockwise, or 180 degrees, which for our purposes, it doesn't matter whether it was going clockwise or counterclockwise. So 90 degrees counterclockwise, right is turning into up, which is turning into left, which is turning into down, which is turning into right. There's a formula for each of these if you are going around the origin, but you're not always going around the origin, so I don't think it's worth memorizing. 90 degrees clockwise, right is turning into down, up is turning into right, left is turning into up, and down is turning into left. And again, there's another formula. 180 degrees is, it doesn't matter whether you're going clockwise or counterclockwise. Right and left are switching, up and down are switching. And the center of rotation is the point other points rotate around. Angles of rotation are usually counterclockwise. This is just a standard so that if I say 90 degrees, you know I mean 90 degrees counterclockwise. And this is because we have x and y, and x comes before y, so that tells us that we're going to go counterclockwise. So when we rotate points, we measure the horizontal and vertical distance from the center of rotation, then determine which direction the new point will face, and draw the image. So if we're rotating around 0, 0, you can measure that this is 4 left and 1 down. And if you're going 4 left and 1 down, now when we rotate 180 degrees left, one of the rules was left turns into right. So the left 4 turns into right 4. And down 1, well, for 180 degrees, down turns into up. So we go up 1, and that tells me S prime is 4, 1. If we want to rotate this around negative 2, negative 3, first we have to find where negative 2, negative 3 is. Then we measure from here. Okay, we're going left 1 and down 2. Now, for counterclockwise, that's this way. So counterclockwise tells me that left 1 is turning into down 1. So this left 1 is going to turn into down 1. Down 2 turns into right 2. So again, I'm measuring from here. When I measure from here, I go left 1, down 2. Now measuring from here again, I go down 1, right 2. So that gives me that here is where B prime ends up, at 0, negative 4. Rotate the triangle 90 degrees clockwise about the origin. So here's the origin. And what we do is we do each of these points separately. So right 2 and up 4, clockwise says right becomes down and up becomes right. So this becomes, that's strange. Down 2 and right 4. So that's where D prime is. Next we have C, which is left 1 and up 5. Left is turning into up, so it'll be up 1. And up 5 turns into right 5. So there's C prime. Repeat for B, left 3 and up 3. Left is turning to up, and the up 3 is turning into right 3. So there's B prime. And now if I connect those, B prime, C prime, D prime, if I connect them in a way that is actually straight, that will give me my triangle. There we go. And now you can see how this rotated around the origin. One last one. If we rotate around -1 comma -2, that's here. 180 degrees. So down 1 is going to become up 1 with 180 degrees. Here, right 4 and down 1. Right 4 is going to turn into left 4. Down 1 is going to turn into up 1. So there's where S prime goes. This was R prime. And Q prime was left 1 and down 3. Left 1 becomes right 1. Down 3 becomes up 3. So there's Q prime. And now that gives us our triangle. There we go. That's how you rotate.